Welcome to today's lesson. I am Siamasaka Kriandens. And so today we are going to look at a lesson in chemistry, and we'll look at the molar mass, how to calculate actually the molar mass. So we go straight to the lesson for today. Well, actually the molar mass and the relative formula mass are the concepts we're going to look at today. Well, the molar mass is actually the mass of a given substance, a given chemical element, or chemical compound in grams, actually divided by actually the substance in moles. And so the molar mass is actually a chemical element or a chemical compound which should be measured in grams, and then you divide by the amount of the substance in moles. The molar mass is actually calculated in the same manner as we calculate the relative molecular mass. However, we include actually units for molar mass, that is grams per mole, as we saw in the definition that actually we need to find the mass of that chemical compound and divided by the amount of the substance in moles. And so this is key to actually the difference between molar mass and the relative molecular mass. Molar mass actually has units, grams per mole, while relative molecular mass has no units. And so also relative formula mass is actually also standing for actually relative molecular mass. In other words, if you find the relative molecular mass, it is the same as actually finding the relative formula mass. And so we'll go through a few questions here to really understand the differences between molar mass and relative formula mass, which is also known as relative molecular mass. And here is our first equation. Calculate the relative formula mass for sodium actually carbonate. As we know, the formula for sodium carbonate is actually this one here. So for us to calculate the formula mass, which is the same as relative molecular mass, for sodium carbonate would be equal to, actually, you look at the subscript for sodium there, which is 2 multiplied by the relative atomic mass for sodium plus the subscript for actually carbon here is 1 multiplied by the relative atomic mass for carbon plus 3 multiplied by relative atomic mass for oxygen. And so this gives us actually 2 multiplied by 23 as the relative atomic mass for actual sodium plus 1 multiplied by 12 plus 3 multiplied by 16. And so this gives us actually, this one is 46 plus 12 plus 48, which gives us actually 106. And so you note that actually the relative formula mass or the relative molecular mass has no units, as we have calculated here. It has actually no units at all. Okay, this is very, very important. So this is actually the relative formula mass or relative molecular mass for actually sodium carbonate, which is actually 106. Okay. So we have another question, calculate the molar mass of sodium carbonate. Now we are calculating now the molar mass. Again, we are aware that this is the formula for sodium carbonate. And so now we are calculating the molar mass. So the molar mass is given by the capital letter M of sodium carbonate would be equal to actually 2 multiplied by the relative atomic mass for sodium plus 1 multiplied by the relative atomic mass for carbon plus 3 multiplied by the relative atomic mass for oxygen, which gives us actually 2 multiplied by 23 plus 1 multiplied by relative atomic mass for carbon, 12 plus 3 multiplied by 16 for oxygen, which gives us actually 46 plus 12 plus 48, which gives us actually 106 grams per mole. And so we have now seen here the difference between actually molar mass and relative formula mass. Okay. So merely here, the difference is just the units. As we saw here, the relative formula mass has no units, which is the same as actually relative molecular mass of a substance. While the molar mass has units, grams per mole. So this is very important because as we'll be doing calculations, we need to express actually these in appropriate units. And so now we are going to look at another question, calculate the relative formula mass for hydrated magnesium sulfate. So at times these compounds can contain water, and therefore the way we calculate actually the relative formula mass or the relative molecular mass, we should now include actually water. So we have magnesium, sulfate with the actually water of hydration. This is the formula, and therefore the relative molecular mass of this compound would be equal to actually 1, that's the subscript for magnesium here, multiplied by relative atomic mass for magnesium, plus 1 for sulfur multiplied by relative atomic mass for sulfur, plus actually 4 multiplied by the relative atomic mass for oxygen, plus actually 7 multiplied by relative molecular mass for actually water, because this is now a molecule. And so we can now add them, which is 1 multiplied by, for magnesium, relative atomic mass 24, plus 1 for sulfur, it is actually 32, plus 4 multiplied by 16 for oxygen, plus actually 7 multiplied by, so relative molecular mass for actually water here is 18, because this is 16 plus that of hydrogen, which is 2, multiplied by 18. And therefore, what you get here is 24 plus 32 plus actually 64 plus 126, which gives us actually 246. We note that this one has no units. Relative formula mass has actually no units. Okay, so this is for this one, magnesium hydrated, actually magnesium sulfate. Okay, so this is the where we calculate it. So now we will now look at another part of the equation. Now we'll look at how we can calculate actually the molar mass for the same actually substance or the same compound. So we have actually our hydrated magnesium sulfate, which is 7, and then we have water there. And so the molar mass of magnesium sulfate, which is hydrated, would be actually be equal to 1 multiplied by the relative atomic mass for magnesium plus 1 multiplied by relative atomic mass for sulfur plus 4 multiplied by relative atomic mass for oxygen plus 7 multiplied by relative molecular mass for actually water. And so we can now add them. 1 multiplied by this one is actually 24 for magnesium, relative atomic mass, plus 1 multiplied by 32 for sulfur, plus 4 multiplied by 16, plus 7 multiplied by relative molecular mass for this one is actually 18. So what we get is actually 24, that is 1 divided by 24, plus 32, plus actually 126. Okay. Plus we need to add for where? Okay. We have actually 64 here. That is 4 multiplied by 16. Then plus 126. And so this gives us actually 246 grams per mole. So we notice that actually the molar mass has the units grams per mole. So the molar mass for hydrated magnesium sulfate would be actually 246 grams per mole. So I thought today we can look at how we can calculate the molar mass and the relative molecular mass or relative formula mass. I hope this lesson has been helpful. I thank you.